Hi guys, I am Marichalam. I am final student in Valtech Engineering College. My project is comparative analysis and design of frame structure with Mivan structure. My batch members are Jagadish and Dinesh Mandi. Introduction. Construction is one of the significant sectors of Indian economy and is an integral part of the development. Today, India's urban population is the second largest in the world, and its future development leads to increased demand for housing. To cope with this problem, according to the Federation of Indian Chamber of Commerce and Industries, keeping in view the existing housing crisis, the country shall need addition of more 2.5 million new dwelling units annually. Keeping in view the gigantic task of providing affordable shelter to masses, adoption of a cost-effective technology assumes greater significance. As a result of experimentation of innovative construction techniques and modern construction management, it is now possible to achieve an overall saving the extent of 10% in the total cost of housing construction compared to the cost of traditional housing. Next, there is a growing realization today that speed of construction needs to be given greater importance, especially for larger housing projects. The Mivan technology has been used extensively in Europe, Gulf countries, India and the other part of the world. Mivan technology is suitable for constructing large number of houses in a short span of time. Using room size forms to construct walls and slabs is one of the continuous pour on concrete. In this system of formwork construction, has inches concrete wall and 4 slabs has to monolithic provides the structural system is one continuous pour. The frames of windows, doors and ducts for services are placed in the form before concreting. Staircase flights and facade panels, scissors and jails, etc. and other prefabricated items are also integrated into the structure. This proves to be a major advantage as compared to other modern construction techniques. High quality Mivan formwork panels ensure consistency of dimensions. On the removal of the formwork mold, a high quality concrete finish is produced to accurate tolerances and verticality. The high tolerance of the finish means that no further plastering is required. Construction of Mivan structure. This is the sample picture of scope and objective of Mivan structure. To compare the frame structure with Mivan formwork structure on the basis of structural analysis and design. To gain knowledge on Mivan technology, since Mivan is a new technology which has empowered and motivated the mass construction project throughout the world. Uses of Mivan structure: 3S. 3 system of construction: speed, strength, safety. Column and tube construction eliminated. Walls and slabs are cast into operation. Specially designed, easy to handle, lightweight, free engineered aluminum forms, carrying out concreting of walls and slabs together. Advantage of Mivan structure: Mivan formwork requires relatively less labor, more seismic resistant, increased durability, lesser number of joints and reduced leakages, higher carpet area, smooth finishing of wall and slab, uniform quality of construction, negligible maintenance, faster completion. Literature review. Methodology: investigation of framed section with Mivan structure, planning, load calculation, modeling using StartPro and also analysis. Design: comparative of frame structure with Mivan formwork structure, resultant and conclusion. This is the typical plan of the building. Center line diagram. Inputs for analysis: material grade of reinforcement Fe415, grade of concrete M25, density of concrete 2500 kg per meter cube, loading, dead load as per code by IS 875 1987 part 1, live load as per provisions of IS 875 1987 part 2, wind load as per provision of IS 875 1987 part 3, codes, concretion IS 456 2000, load calculation, dead load, live load and wind load IS 875 1987, design review SP16, detailing SP34. Partial safety factors: load factors for dead load 1.5, live load 1.5. The above partial safety factors are taken from IS 456 2000. Load calculations: live load and wind load. Wind load is can be calculated using the Indian standards IS 875 part 3 1987. The basic wind speed corresponding to Chennai region is taken from the code IS 875 part 3. The design wind speed is modified to induce the effect of risk factor, terrain confidence, terrain coefficient and local topography to get the design wind speed. Vz equal to K1 K2 K3 Vb. The design wind pressure Vz at any height above mean ground level is 0.6 Vz squared. The coefficient 0.6 in the above formula depends on a number of factors and mainly on the air temperature. B equal to 0.6 Vz squared. Load compression: dead load plus live load, dead load plus live load plus x direction, dead load plus wind load minus X direction, red load plus wind load plus Z direction, dead load plus wind load, dead load plus live load plus wind load on all direction. Analysis of output per frame structure, isometric view of frame structures, 3D render diagram, loading diagrams, shear force diagrams, bending moment diagrams. Analysis output from Mivan structure, isometric view, 3D rendered view left side and right side, loading diagram, plate size diagram, design of frame structure. This is a calculation of roofs of the design. The room dimension is 3.9 into 3.9 meter. Thickness of wall equal to 230 mm. Using M20 and FE415 column. This is a two-way slab. This is a design of frame structure beam design. Given data, width of beam 230 mm, overall depth of beam 300 mm, thickness of slab 150 mm, length of beam, maximum length of the beam is 4190 mm. Concrete M25 and FE415. Beam number 35. This is the maximum length of the beam. Start for output view. This is a column design. Width of column 230 mm, overall depth of beam 375 mm, length of the column is 3000 mm. Concrete grade M25 and FE415. This is the design. The start for output view, column number 21. Start for output view of column. This is a foundation of frame structure. Footing details. Design of Mivan structure. Design of roof slab. Room dimension 3.43 mm into 3.9 meter. Thickness about 200 mm. Using M20 and FE415. This is also two-way slab. Shear wall design. Width of wall 200 mm. Overall depth about 3000 mm. Thickness of slab 150 mm. Concrete grade M25 and FE415. Clear coverage 25 mm. Shear wall design. Dimension of footing in X direction 3 meter. Dimension of footing in Y direction 1.20 meter. Overall thickness of footing 0.5 meter. Depth of foundation from top of soil 1.80 meter. Factor of safety against overturning 2 meter 2.0. Allowable percentage of concrete contact area 70. This is the result of plan and sectional view. Conclusion. The task of housing due to the rising population of the country is becoming increasingly monumental. In terms of technical capabilities to face this challenge, the potential is enormous. It only needs to be judiciously exploited. Civil engineers not only build but also enhance the quality of life. Their creativity and technical skill help to planning, structural design and construct and operate the facility essential to life. It is important for civil engineers to gain and harness to potent and versatile structural design. In this project work, we have done the structural analysis of both framed structure and Mivan structure has been carried out using the StartPro software. Based on the structural member arrived, the structural design was carried out using limit state method. The Mivan structure has great resistance against seismic forces since all walls are made up of RCC which acts like shear walls. References. Thank you.